Let's take a look at dependent motion. So these types of system problems are all going to be, blocks or particles that are related to each other. So in this problem, we have an A, B, and C block, and they're all connected on these pulleys, and that's a really telltale sign that you have a dependent motion problem. So let's take a look at this problem and see how we would go about solving it. So here we have block A moving down at 6 feet per second, and block C is moving down at 18 feet per second. And we want to find the speed of block B. So for all of these problems, we're going to start by establishing our datum. And this is just going to be our point that we're going to establish that's going to allow us to take the positions of each of these blocks, and it's going to be, an equal point that we're going to use for each one. And we're also going to establish our positive direction as down. So let's start by writing the equation for this chord. So we're going to say L, which is the total length of the cord that's connecting A, B, and C. And that's going to be equal to SA, which we're taking from the datum to the top of block A, plus SB, plus SC, which is going from our datum to SC. So we're going to write our length equation as SA plus 2 times SB plus SC. So you take that length in blue plus this length in green twice. You can see we cut in the middle of the pulley, so we could use this length for SB twice. And plus this red length here for SA. So if you add all of these up, that's going to give you the total length. And anything here in yellow, so the top of B and the tops of these pulleys, we are going to neglect that for these types of problems. So this is our equation for our length. And this is important because they don't give us any lengths in the problem, but we need to be able to write an equation that somehow relates these variables. So starting by writing your total length equation is really important. So we can take the derivative of this equation up here. So we're going to take our derivative, and that's going to give us 0 because our total length is going to be a constant, and the derivative of a constant is 0. So that hence again why it doesn't really matter, numerically what our length is. So 0 plus VA plus 2 times speed of B, which is what we want to find, plus VC. So now we have an equation here that we can start plugging in what we're given in the problem, and that's going to allow us to solve for the speed of block B, all because we set up an equation that related all 3 of these variables first. So plugging in what we know 0 equals 6 plus 2VB plus VC, which is 18. And that's going to let us solve for VB, which will work out to be negative 12 feet per second, or we could write that saying 12 feet per second going up. So this is our final answer for the speed of block B. So again, really important to establish your datum and then write an equation that's allowing you to relate all these variables. And you could easily, take the derivative again, and that will give you an equation for your acceleration. And each time they're going to be different, but just start looking for how you can divide up the problem, where you can make your cuts to allow you to write these equations. Let's look at another one. So in this problem, we want to find the time needed for the loaded bee to attain a speed of 8 meters per second starting from rest if the cable is drawn into the motor with an acceleration of 0.2 meters per second squared. So we're going to take two datums because we have a horizontal and a vertical motion. So we can draw our first datum here and our second datum here. So we'll say SA is going to be from our datum to this point A. So that will be our SA. And our SB, we're going to draw from our datum here down to the top of this pulley. So now that we have these established, let's write the equation for the length of our cable. So L is going to be equal to SA plus 4 times SB. And that makes sense because we have, here's our SA length, we just have one of those, but we have 4 cables here that are going to be measured out to be SB. So 4 SB plus SA is going to be equal to our length. So let's take the derivative. So we'll take our derivative, and that'll give us an equation for our speeds. So we can say 0 equals VA plus 4 VB. Or we could say negative VA equals 4 times VB. So this is an important equation, so we're going to highlight this. So now let's take the derivative again for our acceleration. So we can say acceleration of A plus 4 times the acceleration of B equals 0. Or we could say negative acceleration of A equals 4 times the acceleration of B. Now that we know this, we can start plugging in. 4 times AB equals negative acceleration of A, which we know as 0.2 meters per second squared. So that'll let us solve for the acceleration of B, which will just be equal to 0.05, negative 0.05 meters per second squared. And of course that means we are assuming is positive pointing down. So we want to find the time needed now. So we're going to use this equation. So VF equals V initial plus AT. So we're going to say our final speed of B equals our initial speed of B plus acceleration of B times time. We wanted to attain a speed of negative 8 meters per second as given to us in the problem. So negative 8 equals 0 because it's starting from rest, plus negative 0.05, which we just solved for, or for our acceleration of B, times time. So that will allow us to solve for time, and that'll work out to give us about 160 seconds. Thank you for watching. If you like this video, please be sure to give it a thumbs up and subscribe. That really helps support my channel and helps me continue making videos for you guys. I'll see you next time.